This is a quick intro to what's called a parametric plot in Mathematica. A parametric plot is a trajectory plot, or you can think of it as a 1D curve that represents the path of an object or a particle or something like that in a 2D plane or 3D space. So a simple example that I'm plotting here is a projectile in free fall, okay, given some initial velocity. Okay, so we learned in intro physics, we can describe the X and Y position of that particular object independently, each one not depending on the other, just depending on time. Okay, so these are expressions that give the X and Y positions with respect to time, and it depends on the initial velocity and the initial launch angle. Okay, so if I wanted to plot the trajectory of that object, I can do that with a parametric plot. Okay, so in the example here, this top line, I'm just specifying some of the inputs into my function. Okay, that's nice because then when I run this, notice because I've specified all these inputs, when I define my functions for X and Y, which I've done right here, okay, the only thing that is undefined, the only variable is time here, and I know because that's the only variable that is blue. Okay, again, just some things to note here. All of the built-in functions are capitalized, okay, they use square brackets. Here, this would be a common mistake, might be to forget this space. Notice if I forget this space, this whole bit turns blue, then it thinks Mathematica that you defined a variable that is V0 cos, okay, instead of those being two different independent things. Okay, so be careful with that. But everything here is fine. Now that I've defined the functions, I can go down here and call parametric plot that built-in function. It's going to expect a list here of two different items. The list is going to be in curly brackets. In this case, the list is these functions that are specifying the X and Y positions with respect, in this case, to time. Again, it could be some other problem that is not with respect to time, but is with respect to some other variables. Mathematica doesn't care, okay? But they're both with respect to the same variable time. So for the parametric plot, I'm telling Mathematica the range of time with which to plot these two functions against each other. So now when I plot, this is actually a plot of the trajectory of my projectile. So the horizontal axis is really the X position. The vertical axis is the Y position. But this plot represents 3 seconds of motion. Okay, so none of the axes on here are time, but maybe I knew I wanted to just plot the first 3 seconds of motion. Okay, and that's how I can do that. So notice if I just put 1 second in, I just get the curve here. Okay, again, if I wanted to make this fancier, I can use a lot of the same specifications I did for the regular plot call. Okay, and I can also click down here and use this as a simple way to add labels and stuff and things like that to my plot. Okay, another fun example here. This one is fun because it's a spiral, okay? But again, it's plotting this particular function against this function. So this is giving me my X values or my horizontal values. This is giving me my Y values for this range of T. So it's plugging in T from 0 to 19, generating these points and using the points to make the curve that it's drawing here. Okay, you can also do parametric plotting in 3D. Okay, hopefully you guys can see it's not that different than the 2D example. You just got to add, right, another item to your list that you are plotting against. Okay, so now it's plotting, it's evaluating each of these expressions at U from 0 to 20, and it's using that to generate the points that is building this spiral curve here. Okay, and here I've shown that you can, in fact, add whatever things you want to make the plot look the way you want it to look.